Hello, everyone. Today, I would like to start with chapter 1. We're talking about functions. And in chapter 1, let's start with 1.1, function notation. And in this function notations, we have rule for so many things. It may feel as if math is just a bunch of rules. We hope to make this course much more than rules. We will incorporate applications and search for meaning in what we do. However, there is one overriding theme. If there is some mathematical tool, objects, identity, things that we use over and over again, then we give it a name. And our first name things is functions, which is a rule for going from set of inputs to a set of outputs. Okay, so let's start with a definition of a function. So you can see right now, I have a notation, small notation here as f, mostly with use for notation of function, and it's a set of input and a set of outputs and a rule for assigning each input to exactly one output. So the set of inputs is called the domain, or we call it this, the domain of the function. The set of outputs we call the range of the function. So as you see down here, I have like a figure with input. Mostly in mathematics, we notate by x. And it's go to a box named function. And we is a rule right now to make a value as output, which is f(x) here. Okay, keep in mind that we say we read this as f of x. It's not like f times x. Okay, so let's do some examples about functions. I would like to have an example about not a function first. Let's say you want to go to Tahoe, right? And you call the friend in Tahoe what you're supposed to wear. What is the weather in Tahoe at 2 p.m. right? So so one of John's friends say it's going to be 10 Fahrenheit, right? So one of them said, let me highlight this. Okay. Okay. It is the first friend say. The first friend say, right? It's going to be 10 Fahrenheit. And then you double check is with another friend. And he say it's going to be 95 Fahrenheit. Oh wow, that is so different, right? Let me highlight that. So that means you have a question, right? And the answer become two answers. All right. So what clothes should you bring? And should you bring winter stuff or big stuff, right? Should you bring winter stuff or beach stuff? And is this a function? All right. So So this clearly is to see above, I say the word over here, each input must have exactly one output. We mean like in here, if I have a question, right, that about weather in town at 2 p.m. and I got two different answers from your two friends, that's doesn't make sense to you, and we this is not a function. Okay. So so let's go to another example. So if you have you go to maybe a counselor or an advisors to ask about a class for the next semester, right? So the advisor will ask you about the net ID, right? Net ID, right? Because he or she need some information from you, right? So then after you provide the net ID, the advisors can immediately find the record in the computer, right? So we mean what? Net ID, which is the input right now from the system, and and the computer, according to the net ID, will give him a name and the record as the output, right? So this is a function. Okay, this is a function. Okay, so however, sometimes it's happened that you forgot your net ID, right? You forgot the net ID. What happened, right? But you know your CU is by email, right? You know the CU is by email, right? So then you provide your email address, and the computer can still find you. So what does that mean? That means the email address now become input, and the name and the name and the record become an output, right? Yeah. So output. Yeah. So so this also a function. This is also a function. Okay. So the example 1.1 there, right? One input give you two output. Okay. One input give you two output, and that is not a function. Okay. But the example 1.2 below is give you two case. We give you two input, but can still make output. It's the same output, right? So this still a function, okay? Even though they have two different inputs, give the same one output, okay? Two different input give you one input, still can be a function. Okay. So there is a note that you need to know. Yeah. So let's move down to practice on the next examples. For example, 1.3. So I give you a function. Okay, so the function is here as Lx equal to 2x minus 1. And I want you to do what? I want you to evaluate the following expression. Okay. So keep in mind that mostly, I mean, in mathematics, we mostly consider x as an input and f of x is output. So in here, as you see, x right now is in this function is there, stay next to number 2 there, like multiply by 2 and then subtract 1, right? So similar, like you're thinking like, oh, the input double the input and you subtract 1 value, something like that, right? So then you gotta get the output. Okay, so so part A, I want to find f of 3. So how can I find that? All right, f of 3 means what? I'm gonna say input x now is 3, right? X now equal to 3. We make the output is f of 3. So that means what? I have to substitute, I have to change the x over here is an input become 3. Okay, so I have 2 times with 3 and then minus 1. All right, 2 times 3 minus 1. Okay, so 2 times 3 is 6, you know that, right? And you minus 1 and you're gonna get number 5. So that mean 5 is output right now. Okay, I would say like input is 3. My output is 5. Something like that. All right. Yeah. Yeah. All right. So now, part B is similar, but we just change the input to be -1, right? So input now to be -1. All right. So what I do is I'm gonna just change the input to be -1, and I wanna do the operation. So 2 times -1 gonna be -2, right? And then -1, so -2 minus 1 is -3, right? So input is -1, max output is -3. Okay, so make sure that you must change the input to get the output. All right, similarly, the last one you get x equals 0, right? So change everything, change all the input to be 0, right? So 2 times 0 is 0, and that's give you -1 here. Input is 0, make output is -1. So this is some simple problems about evaluate the function. Okay. So now we move down to have some practice. But before doing the practice, I would like to make sure give you a recall about squaring an expression. All right. So go ahead and think about exercise 1.1 over here, and think about if you do x plus 3 squared, is that going to be equal to x squared plus 9, right? Or x plus 3 squared going to be equal to x squared plus 6x plus 9, right? And tell me why you have that, right? So you can go ahead and pause my videos and then think about that and give me the answer, right? So I give you guys 1 minute to think about that. Okay, we'll have pause. Okay, now I'm gonna give you the answer. So answer in this case will be B. Most of you, I think it's gonna be I mean, the one who did choose part A was x plus 3 squared equals to x squared plus 9, right? A lot of students got this mess up because you're thinking like, oh, you will just square each term in here, right? Like for example, square the x squared plus 3 squared, and you got x squared plus 9, right? So that actually is incorrect. But how can I get the x squared plus 6x plus 9 there, right? So let me explain to you. The reason is when you do, let me move this up. When you do, this is a squaring an expression. So when you do a squaring an expression, you may have to remember formulas like, you know, a plus b square will equal to a square plus that formula. But that's, you cannot remember that. What do? You will just multiply the factor by itself. Say x plus 3 square can rewrite it as x plus 3 times x plus 3. Do you agree with me? Right. And then at this point, you will just, you know, do foils as you learn in high school, or let's say if you forget that, let's we go ahead and book together on this. Okay, so this will be x with x and x with 3. All right, and I want to have 3 with x and 3 with 3, right? So now I have distribution going to be x with x going to be x squared, x times x is x squared, right? And then x times 3 going to be positive 3x, right? And then we have 3 times x going to be 3x. And then 3 times 3 going to be 9, right? So you're going to combine like term, right? And you see now 3x plus with 3x here can be combined, and that's, you got x squared plus 6x plus 9 as the answer. And that's the reason why you have the answer B is correct one. All right. So now we're gonna go ahead and move to exercise 1.2. We practice more on the evaluate a function. All right. So I did show you the way to do for 1.1 example 1.3 already. We really help you on exercise 1.2. You can go ahead and pause my video and work on this. Okay, so go ahead and do that and check with my answer. Okay. Okay, I hope everyone did get the answer already for part A. And you see over here, what I did was just substitute 3 into the x, and then you got 18, right? Maybe you got a little bit hesitate with part B, which they just asking you to change the input from x to a. That's all, and you will have just find -5 8 plus 3, and you cannot combine anymore. So that's it, right? So the hardest one going to be part C, which is -5. I mean f of a plus 1. So that means in here the whole input is a plus 1, right? Keep in mind that input now, input x equals to a plus 1 now. Okay, so if you see the all the things inside of the parentheses there, in f f of something here, that's going to be the input. The whole thing of this going to be the input. Okay, so you will have to substitute all of this group into the x. So that you see over here, I have x and 95 times x. So I have to change this x to be a plus 1, right? So now I'm gonna have 95 times with a plus 1 plus 3. Since a plus 1 is input, right? So this is yeah. All right. Okay, so however, you know, if you really want to make it simplify, you should extend it out and combine like terms, the thing that you can combine. So in this case, what you do is you will have to distribute the 95 into this factor, right? So you will have equal to 95 times a, 95 times 91 up, 95 times 1 gonna be 95. So -5 here, right? And then it plus with 3. So this will give us as 95a minus 2, since you combine 95 plus 3. All right, so this might be the answer. Yes. All right. Now go ahead and do the next part for the function g of x equal to 3x squared plus 4x minus 0.5. So keep in mind that we are having x squared there, which is I mean, when you change the input as a group, for example, like a plus 1, so you're gonna get like a plus 1 square, and that you will have to you know, using the informations that from the squaring an expression here, right, to handle that spot, right? So so now let's go ahead and pause my videos and do it and compare with mine. Okay. Okay, I hope everyone that finished D and maybe the substitutes E, F, and G as the input there, right? So I should have this as 3 plus 4 minus 0.5. And if you use calculators or hand calculations, you want to have as 6.5. This guy. Okay. So what about part E? You have 3 times 2 square, which is gonna be 3 times 4, which is 12. And then plus with 8 and minus 0.5. And that's give you 19.5. That's use calculators, okay? The last one, no, sorry, the next one to what you do in here is just because it's a change only the variables from X to the A, since change input from X to A, so you don't want to have any, you cannot simplify anything else, just change the X to be A. All right. But the next one, G, could be a little bit challenge if you, I forgot the square here. If you forgot how to explain out the A plus 1 square there. Okay, so I would like to make sure that everyone can end up, I mean, can have this step as having the input substitute for the X at A plus 1 and there first, right? So after this, you can expand, like you can write as 3 times with A square plus 2A, B in here is 1, right? 2A times 1. Okay, so we is 2A, and then plus 1 square, which is just 1. If you forgot, if you don't want to use formulas, again, go ahead and do a side rule as A plus 1 square, and you write as A plus 1 times A plus 1, and that's give you A square plus 2A plus 1. Go ahead and do the calculation, okay? Then I go to the next part. I have 4 times A and 4 times 1. So 4A plus 4. And then I minus 0.5. All right. So let me make sure to separate this one aside. All right. And then now I will go ahead and move down here and write as 3A square, right? And then 3 times 2A gonna be 6A, and then 3. All right, and you gonna plus with 4A plus 4 minus 0.5. So, I mean, you actually can combine these two as 4 minus 0.5, which is 3.5, right? You want to write that. Okay. And now you can combine like term. So 3A squared must stay. 6A with 4A gonna be 10A, right? And then you have 3 plus 3.5, they give you 6.5. So this must be the answer for this question. All right. So according to this problem, we can go ahead and handle the example 1.4 here. We did have A plus 1, 0, A plus 1 already, right? So that's, I mean, wait a second, let me see. Is that, yeah, this is the same function, GFI, right? Same function, right? So we can use the informations from exercise 1.2, right? So I'm gonna write in here from exercise 1.2, we have g of a plus 1 equal to 3a squared plus 10a plus 6.5. Okay. And g of a is just substitute and changing the input to be 3a squared plus 4a minus 0.5. Right. So now I'm gonna substitute, I'm gonna change this. Okay. So let's box this one as a sign first. Okay, so I will have, let me move on. I will have g of a plus 1. I write down at 3a squared plus 10a plus 6.5. Okay, so since this is a whole group, I must have a parenthesis for this when I substitute it. Okay, and then minus for g of a, which is another group, 3a squared plus 4a minus 0.5. Okay, so let me highlight it to make sure. So you know this is g of a plus 1, which is 3a squared plus 10a plus 6.5. And you also know that g of a is 3a squared plus 4a minus 0.5. Yeah. So then you will have to you can go ahead and cancel something in here if you want. You can see that you can cancel the 3a squared here minus 3a squared here. Okay. But I mean, I myself prefer to open the parentheses. So if before the parenthesis doesn't have a negative sign, you can open it without worrying changing any things. So I have the first one is 3a squared plus 10a plus 6.5. Okay, so the next one have a negative there. So make all the sign after that change. Have negative 3a squared minus 4a plus 0.5. All right. So let me make sure they have equal sign. Yeah. So I'll cancel this. See this 3a squared minus 3a squared, right? I know that I can combine this 10a and negative 4a here. And I also can combine this 6.5 plus 0.5 here. So I will write as 10a minus 4a gonna be 6a. And 6.5 plus 0.5 gonna be 7. So this gonna be the answer for this part. Okay. So I have finished 1.1 function notation, and I will see you in the next sessions later. Let's start here.